Welcome to my world of physics. Now today what we have on the table is the discussion about capacitors which are in both series and parallel connection. Now let's consider a case whereby you have two capacitors in parallel and they are connected to one capacitor in series, and we want to obtain the effective capacitance for these capacitors. Now, in this circuit, let's say we have 4 microfarad capacitor connected in parallel with 5 microfarad capacitor, and 3 microfarad capacitor is in series with them, and we want to obtain their effective capacitance. Now consider first the 2 capacitors in parallel. Recall that the capacitance for capacitors in parallel is C is equal to C1 plus C2. So if you make a substitution, we obtain 4 plus 5, which gives us 9 microfarad as the capacitance for these capacitors in parallel. Now you can now replace those 2 capacitors with a single capacitor whose capacitance is 9 microfarad. So the 9 microfarad capacitor which has replaced the 2 initial capacitors, 4 microfarad and 5 microfarad, which were in parallel, is now in series with the 3 microfarad capacitor. Now to obtain the effective capacitance for these capacitors in series, we now recall that in series 1 over C is equal to 1 over C1 plus 1 over C2. Or we can use the special case, since there are only 2 capacitors now, where we have effective capacitance C is equal to the product over the sum. So that is C1, C2 over C2 plus C1. So this is now equal to 9 times 3 over 9 plus 3, which gives us 2.25 microfarad. So that is now the effective capacitance for these capacitors which were in hybrid of both parallel connection and series connection. Now, if you want to convert this capacitance in the SI unit, which is the farad, then you multiply by 10 raised to power negative 6. So we have 2.25 times 10 raised to power negative 6 farad as the effective capacitance for all these 3 capacitors. Let's look at a second case where we have 3 capacitors. 2 are in parallel and 1 is in series with them. But then we want to find out, we want to calculate the charge on each of these capacitors as well as the potential difference. So these capacitors are connected to EMF of 100 volts. Now, the 2 capacitors in parallel are capacitor 1 of 2 microfarad and capacitor 2 of 4 microfarad. Then they are in series with the 3rd capacitor, whose capacitance is 3 microfarad. Now, the parallel connection, we first of all work out effective capacitance for these capacitors in parallel connection. So recall C is equal to C1 plus C2. So this is equal to 2 plus 4, which gives us 6 microfarad as the capacitance for the two capacitors in parallel. Then in series now, this 6 microfarad capacitor is now in series with the 3 microfarad capacitor. So using the product over sum formula for the special case for two capacitors, we have C is equal to 6 times 3 over 3 plus 6, which gives us 2 microfarad. Now, note that from here we can now be able to get the total charge within the circuit. Recall total charge is equal to total capacitance times the voltage across the capacitor. So Q is equal to CV, which is equal to 2 times 10 raised to power negative 6 times 100, given that the EMF from the source is 100 volts. So this is equal to 2.0 times 10 raised to power negative 4 coulombs. Now, from here, recall that in the original circuit, the 3 microfarad capacitor was in series. And therefore, if it is in series, then it implies that the charge across it is equal to the charge, or the total charge. So we can conclude that the charge on the 3 microfarad capacitor is equal to the total charge, which is equal to 2.0 times 10 raised to power negative 4 coulombs. Now, the PD across the 3 microfarad capacitor can now be worked out from the equation PD is equal to charge over capacitance, which is now equal to 2.0 times 10 raised to power negative 4 divided by capacitance, which is 3.0 times 10 raised to power negative 6. Remember, we're multiplying by 10 raised to power negative 6 to convert the capacitance from microfarad to farad. So this is equal to 66.7 volts. So that is now the PD across the 3 microfarad capacitor, which was originally in series. Now, the PD across the 2 microfarad and the 4 microfarad capacitors, which were in parallel, is now equal to 100 minus 66.7, and that gives us 33.3 volts. And since they are in parallel, the PD across them is equal. The PD across 2 microfarad capacitor is equal to the PD across the 4 microfarad capacitor. So from here we can now obtain the charge on these 2 capacitors, which were originally in parallel. So let's say that the charge on the 2 microfarad capacitor is Q1, and the charge on the 4 microfarad capacitor is Q2. Now, Q1 is equal to now C1 V1, which is now equal to 2 times 10 raised to power negative 6 times 33.3, which is equal to 6.6 times 10 raised to power negative 5 coulombs. Q2 is equal to C2 V2, but note that V1 is equal to V2, which is equal to 100 minus 66.67. So Q2 is equal to C2 V2, which is equal to 4.0 times 10 raised to power negative 6 times 33.3, which gives us 1.332 times 10 raised to power negative 4 coulombs. That is it. And that is how we see it from the physics world. Thank you.